G'day, year 7. Welcome to what might be our last recorded lesson. We'll see how we go, but looking forward to seeing you all back at school next week. Today, we're continuing looking at Pythagoras' theorem, and we're going to be looking at exact form and rounding. Now, I want you to consider the number square root of 7, okay? Square root of 7. When we put a number like the square root of 4, we get an exact number, 2, okay? But if we put the square root of 7, you see that we get this long decimal number on our screen here. So this is going to be equal 2.645, and this will go on forever, 751, ... Okay, so often our calculator screen can actually only store a certain amount of digits. So this decimal would actually keep going on forever. We call it an irrational number because you can't write it fully as a decimal or a fraction. That decimal actually goes on forever. So we have an issue. To actually write this question out, if we're going to write it as a decimal, we need to round it off somewhere. Okay, so if I was to round this to 2 decimal places, I'd go to the second decimal place, which is the 4. And then I look at the third decimal place, which is a 5. And because it's 5 or above, it means I'm going to round up the second one to a 5 as well. So it's going to become 6, 5, approximately equal to in 2 decimal places. Okay, so the DP stands for decimal places. We've rounded that number. Now, when you round a decimal, you no longer have exactly the same value, okay? It's just like if I was to round 18 to the nearest 10, it would go to 20, and 18 is not equal to 20, okay? I've actually lost a little bit of precision there, and I've changed the number slightly to sort of make it more concise, okay, smaller. So what if we as mathematicians want to express this number square root of 7 as an exact value? We actually just leave the square root sign there. So this form over here we call exact form. And the fancy name for this is a surd, okay? So if you ever see a square root number like square root of 7, that's not simplified or not changed into a decimal and rounded, we call that a surd. So exact form means you leave the square root sign there. And the reason is because we want to maintain the exact value. We don't want to round it and change it when we round. Okay, so what we'll see is there's a bunch of numbers. We call these square numbers. When we put the square root under, we get an exact number. So this is just 5. Okay, the square root of 49 is just 7. Okay, because 7 squared equals 49. So if you square a whole number, and it equals another number, then it's going to have a perfectly even square root. Okay, so for these numbers, we can simplify when the square root sign is over them. So anything that has a square root sign and it simplifies to a whole number, then we want to simplify that. For these lower numbers below, okay, if I go square root of 18, I get, again, this long decimal. So if we want to leave these in exact form, then we're going to just leave it as they are. So these ones, we would all leave in exact form if they asked us to. So whenever you're square rooting a number, you should put it in your calculator, and then you should check what the question wants you to do, whether it wants you to leave your answer in exact form or whether it wants you to round your answer. So we're going to do 2 Pythagoras' theorem questions. Okay, and you can see these 2 questions have different requirements. The first one says leave your answer in exact form. So what we need to do is recognize that x is the hypotenuse, so that's going to be on its own on the equation. And then these are the 2 short sides, so it's 5 squared plus 7 squared. Okay, so remember c squared equals a squared plus b squared. That's our Pythagoras' theorem. And then we can simplify the right-hand side. Okay, so we get 5 squared plus 7 squared equals 74. Okay, and then we need to square root both sides. Okay, but when we do this, if we put the square root of 74 in our calculator, I'll type it out again. We get this long decimal, and this question says leave it in exact form. So rather than writing out the decimal, we're just going to leave our answer x, because the square root of x squared is x. We're just going to leave square root of 74 as our final answer. So we're not going to do anything more. We're not going to put the decimal in because we want it in exact form. Okay, however, for this one, it says round your answer to 2 decimal places. So we're going to do the same process. We've got x as the hypotenuse. So x squared equals 25.1 squared plus 12.04 squared. Okay, we just square the short sides and add them together. Okay, so x squared is going to be equal, put that in our calculator, 25.1 squared plus 12.04 squared equals, so we get this number here. Now this number the decimal doesn't go all the way to the end of the screen, so we can actually write that out, 774.9716, 9716. And then we're going to square root both sides. Okay, 774.9716. What you can do as a little shortcut is you can go square root answer, and it will put whatever number was the answer of your last thing that you put in under your square root sign. And then we get our number here. So x equals 27838. Now what I'm going to do is I'm going to write out 3 decimal places and then write ... 27838 ... and it was 27, sorry, point. So I've got the 3 decimal places there, but I want to round to 2 decimal places. So I've got to look at the second decimal place and say that's a 3. And then I look at the next one along, which is an 8, which means I round the 3 up. So it's going to be x is approximately equal to 27.84 centimeters. Okay, this one was also centimeters. So the process is the same. We're using Pythagoras' theorem. We're rearranging to find the value of x, except when we get to this part here, we're going to round 2 decimal places, okay, because that's what the question said, whereas up here, we left our answer in exact form. We left the square root sign because we don't want to lose the precision. All right, good luck with the work today, and I'll see you later. See you next week.